Hello everyone. Today I'm going to introduce the advanced service provisioning features of the Agile Open Container or AOC. In traditional network O&M scenarios, users often see abstract network service configurations when provisioning services. These configurations, however, might not always match the requirements of users. AOC provides a dry run option which allows you to preview the actual configurations to be delivered to devices based on the protocol packets for device interaction. For example, as shown in this figure, you can preview the configurations to be delivered for interconnection with the device on the CLI, greatly simplifying O&M. The dry run process is similar to the actual process of delivering configurations in AOC. The difference is that the changed NE data will not be delivered to the device during the dry run. During a dry run, service configurations are decomposed into NE configurations and a Yang-based configuration change set is generated. Then the Yang-based configurations are converted into device protocol packets and a packet change set is generated. The packet change set includes changes in Yang-based configurations as well as protocol packet configurations. There are also differences between the configuration changes in the dry run and those that are actually committed. For example, if you apply for VLAN 1 during a dry run but VLAN 1 is already occupied, VLAN 2 would be used during configuration delivery. AOC would detect the change and display a message indicating that the committed data is inconsistent with the dry run. In this case, you would need to perform the dry run again. In O&M scenarios, the configuration of a service may involve multiple devices or multiple features of a single device. In such scenarios, if any configuration fails, you would need to deliver a rollback command to ensure transaction consistency, which is challenging. AOC provides the transaction mechanism, which automatically generates rollback commands upon the delivery of configurations. If a delivery failure occurs, AOC performs an end-to-end rollback to restore configurations to their state before the failure. During end-to-end configuration, AOC commits Yang-based service configuration changes based on internal transactions. Internal transactions involve the run, pre-commit, commit, and rollback phases. In successful service configuration scenarios, each configuration on each device goes through the run, pre-commit, and commit phases in turn. Then the device and controller database configurations take effect. If a configuration packet fails to be delivered to a device during the pre-commit phase, AOC automatically performs rollback to restore device configurations to its initial state without saving changes in the AOC database. On the live network, after service provisioning, device configurations may be modified by other authorized users. For this decentralized management mode, it's difficult to manually detect and eliminate the impact of such modifications on existing services. AOC provides a service consistency verification mechanism. You can use the check function to discover the configuration inconsistencies between devices and the AOC database based on a service. AOC provides two methods to eliminate inconsistencies: sync from and sync to. The former synchronizes configurations from a device to AOC. The latter synchronizes configurations from AOC to a device. After synchronization, AOC rebuilds a service configuration instance based on device configurations. This ensures that service layer data is accurate. In routine O&M scenarios, it's difficult to manually roll back configurations that have been delivered or check the packets that have been delivered to devices. AOC records two types of configuration history, including northbound configuration history and southbound configuration history. Northbound configuration history records original operations and automatically generates rollback configurations. You can then select one or multiple commitment points for rollback, or select one commitment point and roll back to that point. AOC records a commitment point and corresponding rollback data upon each operation. Southbound configuration history records operations and the interaction between AOC and devices. In O&M scenarios, it's difficult to trace the configuration source of a device. For example, you may not remember which service delivery a specific sub-interface is established in. AOC allows you to check the list of services carried by NEs and trace the data source based on NE configurations. AOC persists the NE data and its sources to the database. This maintains the relationship between data and its sources. If a configuration conflict occurs due to concurrent operations by multiple users, the system processes the conflict in accordance with the queue. This may cause many security risks. For example, overwriting a critical service configuration may lead to network interruptions. AOC has a concurrency security verification capability. If there is possibility of a conflict occurring when overwriting previous configurations, AOC notifies users of the potential conflict. This is similar to the optimistic lock mechanism of the database. AOC generates a temporary ascending version number based on the actual system version number each time a user edits configurations. When the user commits a configuration, a temporary version number and an actual system version number are used for verification. If the numbers are not in ascending order, a conflict warning is reported. For example, in this figure, the value and version number of A in the Yang database are both 0. User 1 and user 2 concurrently edit A and respectively set the value of A to 1 and 2. Based on the existing version number, AOC generates a temporary ascending version number which is 1. When user 1 commits the data, the value and version number of A in the Yang database are both changed to 1. After that, user 2 commits that the data and the version number of A in the user database is changed to 1. As the existing version number of A in the Yang database has been changed to 1, a conflict warning is reported. In O&M scenarios where services are provisioned to multiple devices at the same time, serial configuration delivery is time-consuming and may cause poor user experience. AOC offers parallel processing capabilities which can configure multiple devices at the same time. If any operation fails, you can roll back configurations as required. The configuration time will not linearly increase with the number of devices. A transaction generally involves multiple service instances. AOC can perform parallel processing based on the default policies of different services. When committing configuration data, AOC concurrently computes and generates data of multiple devices and pushes the data to the devices. This improves the efficiency of processing a single transaction. This slide displays the dry run capability of AOC. You can click dry run to view the result. This figure shows the service segment of user A in the netconf packet to be delivered to anyone. This slide displays the service consistency verification capability of AOC. You can click change content to view data inconsistencies. This slide displays the northbound configuration history capability of AOC. You can view the editing records. Based on the configuration history, you can also perform 3 rollback operations. First, select one commitment point and click rollback for configuration rollback. Second, select multiple commitment points and click rollback in the upper right corner for batch rollback. Third, select one commitment point and click rollback to specified time to roll back all operations performed after the specified time. This slide displays the southbound configuration history capability of AOC. On the device configuration history page, in device configuration, you can check the netconf packets delivered to the device. This slide displays the service tracing capability. On the device configuration page of an NE, you can view the configuration source of a configuration item. For example, the configuration source of L3VPN in this figure is the instance path of the SSP package. That's all for today's introduction on the advanced service provisioning features powered by AOC. Thank you.